Hello and welcome back to my channel. My name is Jeffrey Schultz and I'm a master's student attending Concordia University, Chicago, studying computer science. In this video, we're going to be going over some real-world bash challenges and tasks that we're going to be able to do in real time here. So if you did not watch my previous video going over an introduction to bash and some of the basics that I demoed, I highly recommend you watch that one before you watch this one, because this one's going to make a lot less sense if you don't. It's going to make a lot more sense if you do. So let's begin. So some bash scripting real-world challenges. I'm going to be demonstrating how to complete the following bash scripting tasks. So a script that prints hello world and the current date, user-defined variables and reading user input, some command line arguments, arrays and how to iterate through them, basic math and string operations, being able to make decisions with if, elif, and else, being able to loop through arrays, how functions work in bash, and a bonus one we're going to actually be doing is called the little file organizer. So you're going to be able to see how bash can actually organize all of your different file extensions into alphabetical order. So I will see you guys in the terminal so we can do these. So I'll see you there. These scripts, these advanced real-world scripts that we can do using bash. So let's begin. So the first one was going to be able to create a script that prints out hello world in today's date. So if you watch my first video, please be sure to watch my first video and an introduction to bash before you get into that, because that is going to help this one a lot. This one is going to make a lot more sense for you if you watch that first one. So be sure to do that. So the first thing we're going to do, we're going to say nano, same thing. We went over this in my first video, so this should all be muscle memory at this point, or close to it. We're just going to say nano greet date.sh, and I went over how to do all of this in my previous video, so this is really important to understand. I'm just going to be demonstrating it more hands-on here, so you guys can see how it actually works in real time after learning it. So we're going to say this. We're going to say file name greet date.sh hashtag exclamation point / bin / bash. We're going to say echo hello world. And we're going to say echo today date is, I'm going to say $sign to call a variable, in parentheses date, just like this. So we're going to save this. We're going to add the execute permission to it. And we are going to be able to run it. So there you go. Hello world, and then today's date, and it pulls this. It's a global variable, so it pulls it from my actual computer. Tuesday, July 1st at 2:57. It does it in military time. CDT 2025. So let us clear it and go on to the next one. So for user-defined input in variables, we're going to do nano. We're going to call it input.sh. Same two lines, file name, input.sh. And we're going to say hashtag exclamation point / bin / bash. Oops, don't want that period in there. There we go. We're going to say read -p. And I went over how this worked in my previous video as well. We're going to say enter your name. We'll say username. And we are going to just say echo welcome $ username, because we are calling the variable. So we're going to save this. We're going to add the execute permission to it, input.sh. We are going to be able to run it. So in this one, we're going to say my name, Jeffrey. There you go. Welcome, Jeffrey. So it's really important for this to be able to use the $. Like I said, I went over a lot of common errors in my previous video, but I'll kind of reiterate them again because I think it's important. You're gonna want to be able to. I'm gonna go back into the file. We're gonna go. I think it's we have to use the $sign when we're calling a variable instead of just something like this, because we don't want to do something like this. It's really important to not do this, because obviously we say username is a variable. A lot of people might just do this, but because it's a variable, we got to use the $sign, so something like that. So moving on to the next one, which is going to be command line arguments. So we're going to do nano. We're going to just say CLI args.sh. Create a new file name. We're going to say CLI args.sh. And exclamation point /bin /bash. We're going to say echo. We're going to say first. I'm sorry. Let's just do script name. That might be better. Let's say $0. Then we're going to do echo quote script. First argument $1. So something like this. We are going to just hit Command X, do this, and then we are going to give it the execute permission, CLI args.sh, and now we are going to be able to run it. But with this one, because we're using an argument in the command line and not the file, we're going to just type in something. So we're just going to type in, I don't know, let's just type in anything, cars. So there you go, script name, there's the file name with the execute, and the first argument is cars, because we just typed it in right here in our command line. So it's really important to remember to do this, because a lot of people might not remember to do this. A lot of people might just type something like this because they think you're running it, but when you're doing a command line argument, you got to make sure to not do this because it's important, or else it's not going to print out anything. If you see, if I do this, it does not print out anything. It's just blank. When I type it on the command line, it is good to go. It's really important to do that. And remember, again, to do the $signs for the first argument and the second argument. So there you go. So let's clear it and go to the next one, which is going to be arrays and iteration through them. So let's do the same thing. Nano, we're going to do just call it array loop.sh. Same 2 lines to begin. File name, array loop.sh. Then we're going to do #! \bin \bash on to scripting. We're going to create an array, so we're going to call it colors parentheses. Remember, it's important to do parentheses for our arrays because this is usually in programming people will use curly brackets. And it's also important to remember to have no spaces between here. For variables, for arrays, whatever it may be, no spaces. And it must be parentheses for arrays. Because usually, like I said, mostly in programming you use square brackets, but when you're declaring an array in bash scripting, you have to use parentheses. So let's just say red, green, blue, close the parentheses, and we're going to say for color in, let's say quotes, $, we're going to say colors, curly brackets, colors, and then we're going to iterate through it, so square brackets. This is when we're going to use square brackets for all the elements, or if we want to find a specific element. If we wanted to find the first element, we would type in 0, but since we want to iterate through all of them, we're going to use @ close this, close the curly brackets, close the quotes, colon, we're going to say do an indent, we're going to say echo, quote, color, this is going to be color, just like this. And it's going to print out all of our colors. And to remember to close a for loop, we type in done, just like this. Save this, give it the change mode, execute permission, array loop.sh. We're going to say dot equals array loop.sh. As you can see, color red, color green, color blue. So there we go. Just works just as expected. So let's go on to the next one, which is going to be math and string operations. So we'll just create another file, nano, let's just say math. I'm just going to call it mathstring.sh. So we're going to do the same 2 lines, file name, math string, not capitalized, string.sh, and then we're going to do #! bin \bash, and then we can start scripting. So we're going to say, let's just say a equals 6, b equals 4, let's just say 4, we're going to say echo, quotes, we're going to do sum, we're going to do $, or remember, when we're doing something like this, we want to have the outside parentheses are for the actual variable, calling the variable, and the inside is for the actual mathematical computation. So let's just do a times b. So I'm going to do product, not sum. Let's just do product. And we can also do sum too if we want to. So let's just do that. Let's just do echo sum. We're going to do $, double parentheses, a plus b though, and then close that out. And then for string operations, we can just create one called string equals, let's just say bash, let's just call it bash, and we are going to say echo length of string, and we're going to just say $, and remember, we're calling the string, we went over to do this, curly brackets, #str, because that's the name of our string right there. So then close out the curly brackets, close out the quotes, save this. We're going to add the execute permission to this file, mathstring.sh, and then run it. And as you can see, product 6 times 4 is 24, sum is 10, and then the length of the string, which was bash, is 4. So there we go. That works as expected. Like I said, just make sure to remember how to... I'm going to go open the file again just so you guys can see it. Mastering.sh. It's really important to, like I said, use the double parentheses for any computations. Remember to use the $sign, or remember to use the hashtag in curly brackets when we're calling the length of whatever the variable name is. If this was string 1, it would be hashtag string 1. Whatever the name of our string is what we're going to be for length. That is what we're going to be using for this. This is the syntax of how to do it. So let's clear that and move on to the next one, which is going to be an if, elif, and else block. So let's create a file called grade.sh. So we're going to say the first 2 lines, file name. We're going to say grade.sh. You guys will see why it's called that in a second. Same this line that we have to do at the beginning of every file. Hashtag exclamation point, \bin, \bash. And then we're going to say read minus p. We're going to say enter your score. We're going to say score, just like that. And then we're going to say if. Just remember to put spaces, and if statements use square brackets. We're going to say if $score minus GE, so greater than or equal to 90, space again. We're going to put a colon. We're going to say then echo. We're going to say grade is an A. So then we're going to say next elif, which is basically like an else if, same concept. We're going to say score $score is greater than or equal to 80. Let's just say this. Space, colon, then. I'm going to say echo. Grade is a B. And then the last one is going to be else, and we're just going to type in echo, because this is the last thing. We're just going to do this. We can kind of just do 2 conditions. We're going to say else. We're going to say keep trying harder. You got this. Something like that. And then we're going to be able to close out this. If you remember, it's not done. Done is for loops. But this one is fee. So just like this. So we're going to close this, save that, add the change mode permission to execute. Grade.sh, and we are going to run it. So we're going to say my score is an 85. I must have typed in something wrong. Let me double check, because it should not be printing that. Let me see. $score is greater than or equal to 80, then echo grade B. So let's see. Score greater than or equal to 90. That looks right. Then echo, we're going to say grade A. It can be a little bit too... there she is. We got to put the quotations around this right here. We've got to do that. It's really important. See, this is good that this actually happened, because I want you guys to see what happens. I know I kept saying it. You got to have quotation marks, but this is why you have to have quotation marks around all of this, because we're calling a variable. We have to have quotation marks around these. It's really important. So let's do it again. Let's run it again. 85. So grade is B. There we go. So that's what we expected. That is why it is very important. It is important to have quotation marks around this. Let's run it again. Let's just type in, like, let's say 95. Grade is an A. Make sure this works fully. Let's just type in, we got a 75. Keep trying harder, because it's below 80 and 90. So there we go. Keep trying harder. So now, that is why it's really important to add quotation marks. See, I forgot to do it right there, because I forgot to do it. I didn't mean to, but that is why it is really important to put them, because otherwise you will get an error. So it's too many arguments, it prints out, it's a wacky output. That's not what we wanted. So there we go. So moving on to the next one, we're going to do a loop over an array. So let's do this nano. We're going to call it sports loop.sh. We're going to say the first 2 lines, file name. We're going to say sports loop.sh. We're going to say hashtag exclamation point \bin \bash. And then we are going to do, we're going to say sports. We're going to say equals to basketball, baseball, and football. And do something like this. Close them with the parentheses. So next up, we're going to do for. We're going to do sport in. We're going to do quotes, dollar sign, we're going to say sports, and then curly brackets. There, I'm sorry, curly brackets come before this. Sports, then this. We're going to iterate through all the elements. Curly brackets, close that. So we're going to do all the elements with the @ sign. Close the curly brackets. Colon, we're going to say do. Indent a little bit. We're going to say echo. Sports is sport. Just like this, because that is our variable. We're iterating through this array. So the sport is going to just print out this. And then we're going to just say done, because we are closing a loop. So close that out. We are going to add the change mode execute permission using change mode. Sports loop.sh, and then we are going to be able to run it. Sports loop.sh, and there we go. Basketball, baseball, football, just like such. So make sure to remember to use the quotes as always, and it is really important to use the curly brackets when you're calling an array, and then call the array, and then if you want to iterate through all the elements, make sure to use the @ symbol. If you wanted to call the first element, you type in 0. The first element would be 1, or the second element would be 1. The third element would be 2, so on and so forth, because all counting in computer science starts with 0. So that is going to be it for that one. So the next one, we're going to clear our screen, is going to be a function with arguments. So let's just call it, I'm going to call it add. We're going to do an add function, addfunc.sh. Same 2 lines, file name, addfunc.sh, and then hashtag exclamation point, \bin, \bash. We are going to just say add, just like this. Same syntax as regular programming. This is the one thing that really carries over, the functions. Obviously, there's no data type, because sometimes you would do int, you do void, or you do something like that, something like this. You might have seen this in C++. I do this all the time when I'm writing C++. But no data types in this. This is a little bit more like Python with no data types, or very abstract data types. So we're going to do add, we're going to do echo, quotes, we're going to do sum, and again, we're calling variables here, as you could probably imagine. We're going to do $, double, because we're adding, so 2 things. Do $1, so this is going to say the sum of the first variable plus the sum of the second variable. So just like this. And then we're going to close this function out. We're going to just say add 4, 5, just like this. We're going to add the 2 right here. The 2 different numbers we want to add. So we're going to close this out, add the execute permission to it, and then we're going to run it. Oh, I might have forgotten to add a parenthesis again. Let's double check. I absolutely did at the end of the line right there. So there we go. Close that out. Run it again. And there you go. Sum is 9. Just like that. Because we added 4 and 5 at the end of it. So let us clear and let us go on to the very last one, which is going to be the little file organizer. And this one you're going to really want to pay attention to, because this one is pretty cool, what you can do with this. Challenge we're going to be tackling here is the file organizer. And I actually have the code ready for you guys, because I want to take this one a little bit slower, because it is a little complicated, so I want to be able to explain it. So we're going to open up the file using nano file. I need file organizer.sh. I'm sorry, I got to do something first, and you guys will see why I'm doing this first. cd.sh, and then we're going to do nano file. Now we're going to do this. Okay. So as you guys might see, what I had to do there, this is a big part of why this worked, and why this is pretty cool. So what I did, I typed the same 2 commands, the file organizer and the hashtag exclamation point, \bin, \bash. You got to put this at the beginning of every scripting file. So what I did, I created a variable named file. I said for that file in asterisk, which means all, so it's taking it from all of my files. Do, which is how we do a for loop. We got an if statement in there, or a logic block. So -f, I said take the file using this variable with the $. I said then we're going to use another variable called extension, and we are going to say that is all files. So the variable name, it is all files using the asterisk with a period. So this is going to take all of our SH files, our CPP files, whatever we have, text files, programming, shell files. And this is why I had to go into CD. Why, if you probably saw me type in CD sh change directory, that is because it put this file into a file organizer. It worked. It put it into a shell folder. So now I'm able to just go and into that folder and find all my files with that respective extension. So after we take all the file with that extension, make a directory using -p. This is the same way the read -p works in previous examples. I said use the $sign to get the variable of each extension. So make a variable of each extension. So sh which is why I did that. TXT, C++, Python, Colin, whatever files you might have on your computer, it makes a directory for each one of them. So I said, now that we've made a directory for each of them, move each of the files with their respective extension to each of their respective extension folders. So to be able to close this out, we got an if statement. We close it out using fee means finish, and to close out a loop, we have done. So what this does, so we can exit this. We have the change mode for it. I already have, let's just make sure, ls-l file organizer .sh. So as you can see, I have the execute, so the X there, and the X there. So I have the execute permission, so let's run it. So /file organizer.sh. So if I go to my CD here, I type in ls. As you can see, I now have one for out, so a.out, so Python, so save, shell, text. I have another one up, let me see if I can find another one for CPP right here. Conf, a configuration file. So as you can see, I've now made a directory for each and every one of these using bash scripting for each respective file extension. So for all of them. So this is pretty cool. This is how this works. So I hope you guys enjoyed this. This is all of the scripts that I have for you guys that we have tackled. So I will see you guys back in the slides for a little bit of an overview of everything that we just covered. So thank you very much. I'll see you guys there. Okay, so what did we really just do again in that demo? What did we exactly do? What did we learn? I'm going to give you guys a little overview in a consolidated manner here, a little synopsis of what we just did. So real-world scripting helps solidify your understanding of bash because you can apply really core concepts in really practical ways in real time. So some stuff you could be doing while you're working or while you're working for a company, some things that you might need to actually do on the job. So this is going to be able to really consolidate and kind of combine all of your knowledge here into being able to do something like this. So you saw examples of different types of scripts that do the following: greet users and show the current date, how to use variables, read user input, accept different command line arguments, how to handle and iterate through arrays for dynamic processing, performs math and manipulate strings, use decision making such as the keywords if, elif, and else to control the flow of logic, define and use functions with parameters, and automate tests and file organization using built-in bash tools, as you guys saw. So I hope you guys enjoyed this video. I hope you enjoyed. Be sure to like, comment, share, and subscribe to this channel, and have a great day.